Let's practice rationalizing. Rationalizing means getting rid of the radical in the denominator. If you look at the back of the answer in a textbook, by convention we try to get rid of the radical from the bottom. So 13a, 1 over root 2, is the same thing as multiplying by 1. Same over same is the same thing as 1. Root 2 over root 2 is 1. So this doesn't really change the question at all. However, when you multiply across, we know this is the same thing as root 2 over 2. Root 2 times root 2 is root 2 times 2, which happens to be the square root of 4, which is just 2. It's going to be the inside. So this is rationalized. Let's try the same thing with 1 over root 3. We're simply going to multiply by same over same. Root 3 over root 3 is the same thing as 1. Multiply across. You get root 3 over 3. The square root of 3 times the square root of 3 is same thing as square root of 9, which is just the inside 3. Let's try this one here. We're multiplying by root 8 over root 8. We're trying to get rid of the radical from the denominator. And so the answer is 4 root 8 over 8. Now we can simplify this further. 4 divided by 8 is the same thing as 1/2. So all you see is the 2 on the bottom. And the 1 you don't have to write because anything times 1 is itself. Now the question is, what is root 8? Let's do it up here. What is root 8? Same thing as 2 times 2 times 2, which is 2 root 2. You have 2 friends in jail, you break out, and you have the 2 there. So this is 2 root 2, and these 2 cancel. So the final answer is root 2. Now this last one's a bit more tricky. Pay attention to the cube root here. If you really want to get rid of the radical from these kind of cube root radicals, you don't just multiply once. This is going to be the cube root of 2. This is not going to cut it. We want to do it twice. So this is going to be cube root of 2, cube root of 2. Why would we do it twice? Because you have 3 of these all together. Cube root of 2 times cube root of 2 times cube root of 2 is simply 2. The cube root of 2 times 2 times 2 is 8, and the cube root of 8 is 2. That's the answer. It's the inside. So you're allowed to multiply the insides when you have the same exponent here, the same index. So 2 times 2 is 4. You're allowed to multiply the insides. And the 2's cancel, and so we have the cube root of 4, which by the way is the same thing as 4 to the 1/3. So that now we have no radical on the denominator, so this is fine. And there's many equivalent correct answers. Just for fun, let's try something else. We have 2 over cube root of 2, which was the original question. And let's just for fun just convert this to a fractional exponent. So this is 2 to the 1/3. If you really want, you can even subtract these for fun. What's 1 minus 1/3? Same thing as 3 over 3 minus 1/3, which is 2 over 3. So the same thing as 2 to the 2/3. So this technically is rationalized, and just for practice, this means the cube root of 2 squared. And we're going in circles now. This is the same thing as the cube root of 4, which is what we have here. Let's try another technique here. We're going to rationalize the denominator by multiplying by the conjugate. So when you see this pair here, plus or minus, and you see a radical on one of them, try multiplying top and bottom by the conjugate, which means the same, root 3. Instead of minus, try plus 4. So essentially we're dividing and we're multiplying by the same top and bottom. So this is still multiplying by 1. It's okay. So this is going to be root 3 plus 4 over root 3 plus 4. And so what happens is the denominator cleans up quite well. Let's do the bottom first. Root 3 times root 3 is simply 3. And if you really want to FOIL, you could go outside, inside, but try it out, you'll realize they cancel. 4 root 3 minus 4 root 3 disappears. So the last last times last, that negative 4 times 4 is simply minus 16. So you can see the denominator is simply negative 13. We rationalized this rational expression involving radicals. Now let's clean up the top. Let's do first 4 root 2 times root 3 is 4 times root 2 times root 3 is root 6. You multiply the insides. Let's do outside. 4 root 2 times 4 is going to be positive 16 root 2. Let's make this a bit longer. Let's do the insides. So now we have this times this. This becomes negative 5. Root 3 times root 3 becomes simply 3. And let's do last. This times this now becomes negative 5 times 4 is 20. So 20 root 3. As you can see, we can clean this up a little bit more. Minus 5 times 3 is negative 15. So we verify this answer on symbollab.com. I punched in the same question and I try to rationalize. It shows the steps, and we have an equivalent answer here. They simply multiply top and bottom by negative 1, but this answer is correct. Just for fun, on symbollab.com, if you want to practice, you can type in \frac spacebar. You can try to use the what you see is what you get visual editor here. You can click on these little boxes as well. You can even try to type in the square root button here, or type in \sqrt, which means square root. And you can even use brackets, all divided by brackets, some expression. Now it's your turn. Rationalize. Pause the video.